Demand factors are crucial for estimating the actual load drawn from a service entrance, especially when dealing with multiple TAC units. When planning for new TAC units, applying appropriate demand factors can optimize the service entrance size and prevent oversizing. For TAC units, specific demand factors are applicable based on different time intervals. These include the annual maximum 60-minute demand, the annual maximum 30-minute demand, and the annual maximum 15-minute demand. These demand factors are statistical estimations of the load expected to be drawn by the TAC units over these intervals. The annual maximum 60-minute demand has a demand factor of 0.65. This means that you can expect only 65% of the total connected load to be drawn over a 60-minute period annually. The annual maximum 30-minute demand has a demand factor of 0.75. This signifies that 75% of the total connected load is expected to be drawn over a 30-minute period annually. The annual maximum 15-minute demand has a demand factor of 0.85. This indicates that 85% of the total connected load is expected to be drawn over a 15-minute period annually. Now, let's apply these demand factors to a calculated load of 260,000 volt-amps. For the annual maximum 60-minute demand calculation, we take 260,000 volt-amps and multiply it by 0.65, which equals 169,000 volt-amps. This is the estimated load for a 60-minute period. For the annual maximum 30-minute demand calculation, we take 260,000 volt-amps and multiply it by 0.75, which equals 195,000 volt-amps. This is the estimated load for a 30-minute period. For the annual maximum 15-minute demand calculation, we take 260,000 volt-amps and multiply it by 0.85, which equals 221,000 volt-amps. This is the estimated load for a 15-minute period. When determining the appropriate service entrance size, it's often recommended to base the calculation on the annual maximum 30-minute demand. This interval strikes a balance between capturing sustained loads and avoiding oversizing. Based on the calculations, a new service entrance of 195,000 volt-amps would be appropriate for the additional TAC units. This size provides sufficient capacity to meet the expected load without overloading the service equipment. Always consult local electrical codes and regulations when sizing service entrances, as these codes provide detailed guidelines and requirements. Furthermore, consider future expansion plans when sizing the service entrance. It's often prudent to add extra capacity to accommodate potential increases in load due to additional TAC units or other equipment. Ensure that the service entrance equipment, including conductors, breakers, and transformers, is adequately sized to handle the calculated load. Consult with qualified electrical engineers and contractors to ensure the correct sizing and installation of the service entrance equipment.